This is a short demonstration to show how it may be possible to improve safe working conditions in and around the DC bus bars which are inside the traction converter cabinets in CSR class locomotives. There are two sets of bus bars in such locos, and they look a little bit like this. This is a scale model. It's full scale from left to right, but represents only about 0.4 metres of what is possibly about 1.5 metre long runs inside the actual locomotives. The locomotive, when it's operating at its maximum capacity, produces a voltage of 1600 volts maximum between the two bars, and resistive dividers within the traction converter cubicles divide that bus bar to bus bar voltage in two with a resistive divider, and the centre of which is earthed, such that when there's 1600 volts between the bus bars, each bus bar is 800 volts with respect to ground or the frame of the locomotive. I have a power supply here which is adjustable up to the 1600 volts maximum, which is what occurs in practice, and several measurement means. The first is an analogue voltmeter here, which is arranged to read from minus 2000 through 0 to plus 2000 volts, and I've especially marked 1600 volts here as the maximum voltage which occurs on those bus bars in practice. The second voltage measuring equipment is a multimeter, which is connected between the positive, or the right-hand bus bar, and ground, and so it measures exactly half. And this is here because we'd like to see if we can measure the voltage when it's very low, and of course to measure a very low voltage on that scale is quite difficult. The third indicator is a light-emitting diode arrangement here, which glows over the entire voltage range. So the first thing to do is to switch it all on and to raise the voltage on the bus bars up to 1600 volts, which is about there, and you'll note that the voltage measured here is about half that value. The device we're evaluating here is a field mill based device, which is a non-contact DC voltage indicator, and it was developed specifically for use by emergency services personnel attending accidents and incidents involving, for example, trams or trains which operate on DC supplies. So what we can do is to turn this device on. You can probably hear it operating. It's a field mill type device which involves a mechanically driven electrode which alternatively shields or unshields a fixed electrode, giving rise to what's called a displacement current. That displacement current is alternating, it's amplified and then used for measurement and audible alarm purposes. So what I'll do is to take this and I'll point it at the bus bars in question. And you can see that from a distance of around about 100-120 millimetres, it can very readily see the voltage present there and offer the appropriate visible and audible alarm. That's a worst case, of course, and it's probably much more useful to reduce now the voltage to perhaps a tenth of the value that it previously had, namely 160 volts instead of 1600 volts, in which case the voltage between the bus bars and ground is 80 volts each. We can take the same non-contact detector and see if we can measure or detect at least that reduced voltage. Finally, the capacitor system may be considered safe and able to be worked upon when the voltage is as low as around about 20 volts. So what we can do is to reduce the voltage now from one bus bar to ground to about 10 volts, which is about there. You can see it's practically unreadable, but you may also be able to see that the light emitting diode is still illuminating. I can now change the sensitivity of this device to maximum and see if we can detect 10 volts or 20 between bars. That quite clearly shows that even 20 volts between the bars is readable, and that this type of instrument at least looks promising for our purposes. Thank you.